It's MRob here to talk about the distributive property that you already know. Here's the property here at the top of the page. This property is also located on the property page of your mega notes. We've done things like commutative property, associative property, identity, inverse, and here we are with distribute. Distribute means to spread things out. And the letters represent numbers. So we're going to take this first number and multiply it by everything that we have in the parentheses. And you get A times B plus an A times C. So what you have is the product of something with the sum is the same as the sum of the products. Now remember, with letters, you don't have to see the times sign. It's implied. Okay? A product times a sum is the sum of the products, is the very professional way of saying it. And again, I'm sure none of that makes any sense to you right now, but that's fine because I said this is the distributive property you already know. So let's go back to the stuff we've been doing that includes just numbers. So from the last chapter, we were talking about tax, tip, and discount. So let's go over 2 different ways to do a problem on tax. First, you can find the tax. And let's see, we have the word problem up above. We're going to do 8% tax, and we're going to do it on $20. So the 8 is the percent. We're going to label this tax. I don't know the tax, and it's out of $20. This is a review from the last chapter. Okay, cross multiplying is the crowd favorite method for solving it. I put the equal sign down first. 20 times 8 is let's see, the 160. 100 times x is 100 times x. If you don't know what something is, you can't give me a numerical answer. So I have an expression. And to get x by itself, we divide using a fraction bar because it's nice and neat, and we're working down by 100. And you put this in the calculator, or when you divide by 100, you move the decimal to the left 2 places, and I get $1.60. And again, we've labeled it, so if you look back, the X was the tax. I'm looking for tax. $1.60 is the tax. And the same problem done with the Purdy formula, where the part equals the rate times the total. I is looking for the part that is tax. My tax rate is 8%. If you don't put the percent sign in, it won't come out correct. Otherwise, you would have to change it to a decimal. 8% is equivalently written as 0.08. And it's out of $20. Of also means times. When you put this in the calculator, you get $1.60. This is a great review because I'm telling you, this is the most important stuff you're going to do in 7th grade math, because as an adult, you will be working with money often. Okay, so let's do that problem again, a different way. Instead of finding the tax and then adding it, let's do everything all at once. And let's do it so that we can get the after-tax amount right away. So one of the most common mistakes, for some strange reason, is students subtract for tax. Tax is extra cost. It is additional. You have to give that to the government. So I normally pay 100% of something, and then tax is added to it. So 8% added to 100% means after taxes, you're paying 108%. And I is wanting to know what is my after-tax amount in cash. And it's out of an original $20 because I decided to make the question about $20. So we're going to do what we did before. We're going to cross multiply 108 times 20 and 100 times x. And I'm not going to show all the work because I'm running out of room. And the answer will come out. So you do 108 times 20, and then you'll end up dividing by 100. You'll get an answer of $21.60, which we know from the last example, if you took your original $20 and added your $1.60, it would come out the same. I probably should have left some room for that So I'll write it over here. 20 plus $1.60 is $21.60. Comes out the same. Should be the same answer. It's the same question. Okay, so if we were doing that with the Purdy formula, the part I pay, I don't know. The rate I pay is 108% of the original 20 bucks, which this is actually nicer for showing the work. Purdy's great when you have the rate and the total. It's more work when you don't have the rate and the total, and I haven't gone over that because I didn't want to do more work. Okay, so, and we've done this before. This is going to help you understand distributive property. So instead of a problem where I know the amount, let's say I don't know the original amount. When I don't know something, I use a letter. So I have my original cost that I have to pay, and I don't know it, so it's X. And then I'm going to add in the tax. And we know from the Purdy formula, the tax is 8%, which if I write as a decimal is 0.08 of the original cost. Okay? My first X has an invisible number in front. The coefficient for that X is 1. So I'm going to write it in so it's easier to understand. A X or 1X is the same thing. And you remember that that's when we did the problem the first time. We did the 8% tax and we added it to the original. And then the second time we did 108%, which is 1.08 as a decimal. And remember, the calculator, if you put 108 second left parenthesis, enter, it'll change it to a decimal for you if you don't know how to do that yourself. And it's times the original total. So these two things are the same. This should also help you understand the last lesson on simplifying expressions, because both of these have the same letter, which makes them like terms. Since they're like terms, we can add their coefficients, 1 and 0.08, which we know is the same as what we have on the other side, 1.08. This is like distributive property. Look, x times 1, 1x, x times 0.08, 0.08 times x. It's distributive property. Okay? Again, maybe you didn't like that. Maybe you didn't get it that time. That's okay. I don't expect you to get everything on the first question. Let's do another example. How about a discount? So it's slightly different. So when you get something discounted, you have two ways you could do the problem. You can take your original price, which we don't know, so we're using X, and discounts are subtracted. So the discount is 30% of 30%. I'm going to write it as a decimal. I could use the percent sign instead if I wanted to, of my original amount of money. You could do it that way. I'm going to stick the 1 in here. Or you could just do it all at once. And if you take 30% off, what percent are you left to pay? You're left to pay 70%. So I can put 70 with the percent sign times X, or I can do 0.70 times X. And look, this is like distributive property. Both of these are X's. So you can add the coefficients. They're like terms. And 1 take away 0.30 is 0.70. And, reversing the work here, X times 1 gives you 1X. X times a negative 0.30 gives you a negative 0.30X. Okay? So what I want you to do is you're going to do these on your own. Give me the price after tip. Do it two ways. Find the tip and then add it on, or give me the price after tip right away. A couple markups, a couple markdowns, and then some other stuff that you might not have done, but you probably know it. I've been trying to do some of this in class. I'm going to use distributive property to do 25 times 12. 25 times 12, a lot easier. So I'm going to keep the 25. I'm going to break up the 12 into easier numbers, like 10. Since we are a base 10 number system, it's good to use tens. 10 and 2. Is this not equivalent? it's equivalent. 10 plus 2 is 12, and then I'm going to multiply it by 25. Instead of doing it with all those algorithms let's do it this way because it's easier. Anytime I multiply something by 10, all I do is add a 0. And doubling 25, I'm sure lots of people can do quick. That's 50. And 250 plus 50 is 300. And we did 25 times 12 faster than somebody who'd used the old algorithm. So that's distributive property. Okay, for example, one more time. Let's check out the last one. Let's do distributive property, do 45% of 50. I'll keep the 50. And remember, I said we're in a base 10 number system, so let's use tens and to make 45%. So I got 10%, and then I'm going to need another 10%, and another one. This is not pretty, but and another one. Oh, I'm running out. I got 40. I'm going to have to use my eraser. And then I need the 5. Okay, so 10%, remember, is pretty easy because all you got to do is take the decimal and move it left one place. So that would make this 5.
We will begin dismissal with our student walkers, student drivers,
and if I want
road with a friend, as well as
5%, I just need half of 10, right? So here's half. I normally press pause, but you know from the last video, I had so much trouble pressing pause that I just didn't do it this time. Okay, I'm at a school, people getting dismissed for buses. Okay, so 10% is 5 because I moved the decimal to the left one place. 5% is half of 10%, so it's half the answer. It's just all proportional. Oh my gosh, this stuff fits together so well. This is why I love math. You see how I related it to the proportional stuff, and I related it to the last lesson on simplifying expressions. So 5 and 5 is 10. Another 5 and 5 is another 10, so that's 20, and a 2.5, a 22.5. And that was mental math. We call this mental math, and I can do that pretty darn quick. Okay, so you guys have to finish the rest on your own, and it's not with a calculator. We're doing distributive property. So I want to see these parentheses and multiplying it through. Have a good day. If I can find the stop button somewhere. We'll see how that goes.
Yes, hello again, my dear. How are